All right, everybody, so down to business. We're on our last class on classes. So what are we going to do today? We'll do a recap. We're going to talk about scoping and class customizations and equality. We've actually covered all of this. This is just topics we've already covered, and we're going just a little bit more in depth on them. So from a recap perspective, let's remember what the syntax for a class looks like. Class is the keyword in the name of our class. Indent it. We have our constructor, which begins with it, right? Please be very careful with the indentation, even with the files module quiz and the assignment that TAs and I are grading. People are still not indenting. It's a common theme. Ifs, fors, classes, everything really needs to be indented. So make sure you pay attention to that. When we're dealing with classes, these methods, they're just functions. There's no magic here, really. The only magic, I guess, is the fact that this self parameter, you must declare the self parameter, but when you instantiate your class, you never have to pass that. The interpreter gives you that for free. So, tying together what we learned from functions into here, if I wanted to have a default for the strength score, which is STR, and a default for the defense score, what would I do? How would I put a default in there?
You just put a number after like self.string. You just put like 10 or whatever.
You say you put it where?
You put it after the equal. Like you just make it like that. The default.
Here?
Yeah.
Okay. Anybody else? Default for the parameter. Yeah, you put it here. If you put it here, absolutely everybody would have the value 10.
Oh, that's right? What you were saying.
So the default is always up here. So this way, if I wanted to pass in 1,000, I could put 1,000. I pass 1,000, the strength score will get you 1,000. All right. Now, when I instantiate a class, right? I don't have to call that underscore init. There's no concept of self when I instantiate. I just say the name of my class, and then I put the parameters that it needs inside the parentheses, right? When I have defaults, I don't have to put anything, right? So in this case, both Woody and Picky would have the defaults. I think it was like 10 and 5. But if I didn't want to use the defaults, right? I can always say, okay, the name of my parameter, the defense score equals 10. Okay, so I could overwrite that. We spent a fair amount of time talking about attributes, specifically instance attributes. And there's two key things to remember, and it's fairly simple. When you are inside your class, when you are inside a method, we have to use the word self dot in order to access any of our attributes. So inside the constructor, it's self.help, self.name. When we're outside of our class, when we're in the main or we're in the global scope, we use whatever variable is assigned to our instance. So here I say Woody.strength. Would it make sense to say self.strength out here? Because what if I had 20 characters? You wouldn't know who self was. So inside, we use self. Outside, we use the variable. So we expanded our knowledge a little bit to these class attributes. So these are attributes that are applicable to any character. And the metaphor that we use here, we said all of the characters in our game were born in the same kingdom, right? When we were using that menu metaphor, we had the concept of the tax rate. We said the menu is always going to be used in the same city, state, whatever. This is slightly more complicated, but when we are inside of our class, we can either say self or use the name of the class. I'm going to advocate and suggest you almost universally use the name of the class because they could change. We looked at that, but we'll take another look at it. So when I'm inside my class, again, I have to use self or I have to use the name of my class. When I'm outside, kind of that same pattern, I can either use the variable or I can use the name of the class. So I can say Woody.birthplace or character.birthplace. This is the tricky bit. This is why I said I suggest you almost always use the name of the class. Python allows the instances to overwrite that value. I don't like that. A lot of other languages don't allow you to do that. But pay attention to what I did here. Inside this method, I said print self.character_name born in, and here I used the name of the class, but here I used self. So here on this line, I changed birthplace. I changed that character Hickey to Helm's Deep. And so this gets a little confusing. Woody, I didn't change anything. It says Woody born in Kingdom of Asgardia or Kingdom of Asgardia, right? It used the same value. But for Picky, it has two different values. So it's very confusing. So when you're going to be playing and using these on assignments and on quizzes and stuff, just remember, like, always sort of test with self or the class name, right? And you'll very quickly see the difference and you'll see what's going on. But I really don't like this at all. Okay, this is just to give an idea of the scope, how big some of these classes can get. This isn't even a very big class, but just to give you some idea, again, I have a class, I have a class level attribute, I have my instance attributes, and I have a bunch of methods here. So just get comfortable with using classes, write your own classes. Next, I think Wednesday, we're going to start on designing our own classes. So we're going to actually be drawing. We're going to be coming up with the design for our classes and then implementing them. Okay, so all of these attributes, I need to tie something back that we discussed when we talked about functions. So recall with functions, we had this concept of scoping. Now, this stuff, again, very useful if you're going to be like hardcore computer science. Reasonably useful if you're just going to be coding stuff. If you're kind of in, again, the cyberspace, I think more of an appreciation of this. When the interpreter is looking for variables, when it's looking for functions, it looks in certain places in a certain order. So first, it looks in something called the local scope. And that's basically this area in memory where the interpreter is currently operating. The easiest way to think about it, actually in Python, is what level of indentation are you at? So if you're inside a for loop, well, it first checks for the variables at that level of indentation. If it doesn't find it, let's say your for loop is in a function. Now it looks inside the function. If it doesn't find it there, then it goes out. It looks for it in the class. If the class is then just in some global scope, it looks in the global scope. The last place it looks is this thing called the built-in scope. And that's really just a fancy way for saying that's where all of Python implemented functions and variables are. So that's where we have integer and string and list and range and all that good stuff that we seem to get for free. Okay, so if we have this very simple person class, how many variables called age exist in here? A little bit of a trick. Is it 1, 2, or 3? 3? Yeah, it's a good guess. There's actually 2.
Oh, very good.
Yeah, just these 2, because this inside the constructor, if we remember, we'll step through it in Python Tutor, right? That's sort of ephemeral. It's kind of just happening, you know, as the class is being constructed, but it's literally these, right? So if I jump out to Python Tutor here, here's that same code, right? So I have my person. So the interpreter steps over that, right? Now, again, the interpreter just allocated in memory this thing called person. It said, look, there's a function, a constructor. It knows nothing about it, doesn't know what's in it at all, right? It's only here when I instantiate this first person, Now I see the word age appear. So there's my first variable. Now I'll go ahead and construct Erica. There's my second one, right? So it's only, when I say variable, it's only at that point in time when it's holding data. What about with the class scope? So the class scope, I have default burger. Here I have Erica and Caleb. Same thing I had before, but I'm using a class level variable. How many instances of default food do we think we have here? 1, 2, or 3? One. We have 1. And we can take a look at this. And the name should maybe give it away a little bit. Class level, right? So here, let me just pen this in here. If I say default food equals salad, something like that. Even if in here, I say they're going to use that value. Notice where default food lives. Now it lives over in this thing at the class level, right? So there's only one instance of it. So when I have Caleb, when I have Erica, whatever, right? Oh, I gotta fix that. But you can see it doesn't exist anywhere else. Since this is a class level variable, I have to do that. So even though I'm using it, you only see default food once. This is the part of Python that I really hate, right? If I decided to take Erica and for whatever reason change Erica's default food, right? Like it's Erica default food equals, I don't know, water. No. I create Caleb. I still only have one default food. It lives out there on the person class. I create Erica. I still only have one default food, but oh shoot. Now that I said Erica.default food equals something, another one popped into existence, right? So this is where it gets like really tricky because Erica from a certain perspective has different default foods. Like I said, other languages don't have that so much. Okay, so let's just jump right to this one in Python Tutor. We looked at something similar when we were looking at global and local scope. You got to pay attention to this. This is definitely the type of thing you're going to see on a quiz. So I have a class called test class. I have a class level attribute called test. In my constructor, I have an instance called test. In my function, I have a parameter called test, right? So here, when I run this code, oh, and I also have a global variable test out here, right? When I run this code, I construct my class, it jumps into the constructor. We can already see where some of this confusion is going to come from, right? I have this over here, I have this over here. My gosh, it's all over the place. When I go to call this function, this is what the interpreter is going to do. It's going to say, okay, what's in my local scope? So what's at my level of indentation? Well, right here I have test. That's going to print out local. Then it says self.test. Well, where is self? Well, self is my instance. That's here in my constructor. And then finally, my class level. So if this is all correct, I should end up seeing local, instance, class. If for whatever reason this didn't exist, right, then the global variable would be used. Okay. So this is the new stuff, but it's not really new. It's called class customizations. nothing really makes a circle class different from a character class, different from a menu class, other than the attributes and methods. That's the only thing that sort of disputes them. So here, if I have a circle, right? Well, we know pi is pretty constant for any circle. But what differentiates one circle from another? It's radius. That's it, right? What's the radius? Half the distance from the center to the circumference, the outside of the circle, right? So I can have 20 different instances of a circle. The only thing different between circle 1, circle 2, circle 3, circle 4 is their radius, right? So we've already looked at this constructor. That's making our, how do I put it? That's making our instances unique, right? So again, we can run through the code. And by the way, if I haven't said this, everybody should be making use of Python Tutor, right? It's very, very useful, you know, especially in quizzes, right? Where it's like open book, you can use whatever resources. This is a great place to look for stepping through your code, seeing where variables are set, all that good stuff. Right. But this stuff isn't very interesting in and of itself. Where it gets interesting is some of these other methods. So we're going to take a look at how to solve this problem we had with printing out like garbage for our class, right? So if I have a circle here, I'm going to construct this circle with a radius of 1, calls its constructor. Now, if I say print circle, I get this garbage here, right? I get where that function basically is in memory. It's not very useful, but I can override, or I can use this custom method here, this custom function called __str. Okay. Now, as long as my indentation is correct there. Now, when I go to print my circle, the interpreter is going to say, ooh, you have a function called __str__. Now, it's going to call that function and return, not print. It's going to return whatever's in there. So my function is going to return that. And then now this is going to print out to the screen circle 1 instead of that garbage. So we'll take a closer look at that when we jump into EdStem. Now, these are enumerated in SciBooks. I am highly unlikely to go through these in any level of detail, but I'm going to expect you to know these. So this is a great spot for you to carve out that page in your notebook with stuff you need to remember. This is one of those things you need to remember. So when I want to compare any object, an integer, a float, a circle, a square, a menu item, whatever, right? There's this whole bunch of __ internal functions. And you can kind of use your intuition on this. LT is less than, LE is less than or equal to, GT is greater than, GE is greater than or equal to. What do these do? Well, less than checks if instance 1 is less than instance 2. What's the interpreter doing under the cover? And we can see this in Python Tutor at some point. It's literally calling that function that you declared on your class. So here's a whole wall of them. Here's another whole wall. So none of these should be a real big surprise, though. Y'all know how to do all this. So these are addition, subtraction, multiplication, true division, floor division, and or, right? Pretty straightforward. If I want to add 2 circles together, subtract 2 circles. You have to decide what that means to subtract 2 circles. I'm going to make a claim you probably want to maybe subtract the radius, right? There's 3 fun ones listed here that are slightly different. Right? When I want to convert my circle to an integer, when I want to convert my circle to a float, why would you want to do that? I don't know, but you could. But you can also determine the length of your circle. Maybe you want to make the claim that the length of a circle is its circumference and return that. Okay. So let's see what this looks like in action. So recall, we had this menu item, right? So I have a menu item, has a whole bunch of attributes, right? Here's my main. I'm going to want to print out this menu item, which is eggs for $4.50. So when I run that up, I get this garbage. Okay, so I want to write my own string function. First thing, I see a lot of people doing this. Remember where it has to go, and your hints are your levels of indentation. So here, I certainly don't want to put it inside my constructor, right? Because I want to call it at other points in time. So I'm going to put it out here at my class level. So def underscore string. I always have to take self. And here, now I can return whatever string I want. So I'm going to say return. And in this particular case, I'll do a format string. And I'll say, remember, I got to do self everywhere. Self.name is $ self.price. 0.0 to F to make it a float. So now when I print my menu, eggs is $4.50, right? I could put other things in here over time. I can say has len of, let's say, ingredients. Has blank ingredients. Oops. What didn't I like here? Ingredients. Oh, self. Self.ingredients. Okay. So eggs is 450 has 0 ingredients. Okay. So let's look at another example of customization. Length. Run this code. Notice the ... dots. Look at print menu and how we hard coded the number 20 in there. Okay. So this is code that we worked through in some of these other sections. When I run this up, I get a nice menu, eggs, waffles, pancakes. And I got these whole bunch of dots here. And I got those whole bunch of dots because of this. I just hard coded the word 20. If I change this to like 15, I have fewer dots. If I change that to like 10 or something, I get even fewer dots, right? But why do I have that magic number? Well, I have that magic number, right? And we did this on one of the quizzes with the songs. If I wanted to say, I want to get the length of the max of the self.menu items. So from menu items, I want the maximum one. And then tell me how long that is. When I run this code, I'm going to get this error. Type greater than not supported between instances of menu item and menu item. Cool. So let me now write a comparison for my menu items. So I'll go up to my class, menu items, def underscore underscore greater than self. Now there's a second parameter here, which is other. That's the other thing I'm comparing to. Here I'm going to say return the length of self.name is greater than other.name. So now when I run my code, I'm making progress here. Greater than not supported between instances of int and string. Okay, what did I do wrong there? This needs to be a length. Cool. So I made a little bit more progress. Now I got rid of that greater than error. Object of type menu item has no length. Okay, so let's implement a length function. Def underscore underscore len of self, return, and here I'm just relying on this name attribute in my class. So menu item has no in the right spot here. Oops, I forgot the underscore underscore here. Cool. So now it actually is, it doesn't look good, but it's perfect, right? It says, well, what's the longest thing I had in my menu? Well, it's pancakes, right? And so it gave me the exact correct number of dots. Now, just for aesthetics, you know, in my program, I might go in here, you know, and just take that max length and just, I don't know, add 5 to it or something. So now if I end up creating some menu item later on, so let's add something else in here. And I say waffles with strawberry. It's going to automatically move everything for me. Okay, so that's all there is to class customization. It's a matter of just putting in your notebook a whole bunch of these. I'm not going to quiz you and say, what's the name for true div? I'm probably going to tell you that, but you're going to need to know when you get those error messages that say, hey, menu item doesn't have a greater than sign. You need to use your intuition and be like, okay, well, it's none of these. Oh, yeah, it's probably GT, right? And then just know to implement that on your class. Okay. Equality is a special case of class customization. So this, I know a lot of people struggled with this, and this just comes around in everything we do, is versus equals, right? So if I have 2 instances of my characters, Woody and Picky, if I say Woody is Picky, I think we all agree that's false. Well, I know that character is not that character, right? And if I say Woody is Woody, well, yeah, it's the same variable. Sure, that's pretty obvious. What about in this case? So I have my character. It has the same values. Are these 2 things the same? Is that going to return true or false?
True.
False. Because remember, is location in memory. That's all it is. Whenever I say is, it's just location in memory. And so this thing is in a different place in memory than that. The only time that would sort of work is when we get into the equals equals. I want to show you how to do that. So remember when we had something like this, we had 2 lists. A is B is false, but A equals B is true. But because they contain the same things. So a list contains the same thing. That's going to be the same thing with a class. Does a class contain the same things? So here, right now, if I do this, this is going to say it's false. And it's false because I haven't written an equality method on my class. But I can. So in that long list of classes to remember, there's underscore underscore equals underscore underscore. So I can implement the equality of 2 characters by just checking their name. So remember that. I'm defining equality as the names being equal. I can do whatever I want, but for the purpose of the next 2 slides, equality is dictated by the names. So in this case, if I say player 1 equals players 2, assuming you have that equals method, is that going to return true or false? Well, true, because they're both Woody, right? It's just going to compare Woody. What about now? Is that going to return true or false?
You said it compares only names, right?
Only the name, exactly right. It's only going to compare the name, so that's also going to return true. only if I went back into that equals method and I said return self.name equals self.name and self.strength equals other.strength and so forth. All right, so let's look at this in action. So back to our menu item example. Yeah. Okay. So both Dan and Kara have eggs, but they are not the same. So here's my menu item class. Nothing new here. Here's an implementation of string, a little bit more advanced than what we looked at a minute ago. Here's my menu. Here's my main. So I'm going to create Dan has eggs and Kara has eggs. When I run this, it prints out that for Dan, it prints out that for Kara, but it says it's false. And I would make the claim that they're actually the same thing. So if I want to make them the same thing, again, I just say def underscore underscore EQ underscore underscore self and other. That's the only sort of tricky thing with some of these special methods. You kind of have to use your judgment when you're going to pass a parameter other. But equals, greater than, less than, anything where you're comparing, you should use your intuition. Well, I need two things. So here, now I'm just going to say return self.name equals other.name. So now my check, if Dan's eggs and Kara's eggs are the same, returns true. There's some other fun stuff you can do here. So, did I not write this in here? Oh yeah, I have a part 2. Okay. So I'm trying to give you something that would work, kind of in real life, right? So like when I thought of this metaphor, I was thinking, hey, how would I write, a menuing system in a restaurant? So here in our diner, the waitstaff use shorthand, strings, right? So imagine I was building a computer system in a restaurant, and sure, they're the waiter or waitress is going to take stuff down on a notepad. Let's assume we can scan that, right? And the scanner can pick up their language, what they wrote, and say, okay, I want to now find that menu item, put it on the ticket to go, print out back. How would I do that? Well, in this particular case, if I tried to say, I have these menu items, eggs, pancakes, waffles, right? If I want to say, do eggs, the menu item equals the string eggs, right? That's going to print out false. Let me just figure out what's some codes borked here. Let's see. Oh, interesting. Okay. It did what it was supposed to do. So I have this main method, and where this errored out was right here. I want to check if the class eggs equals the string eggs. And so again, I'm trying to picture in my head here, waitstaff writes on a pad, eggs, pancakes, waffles, feed it into some computer system that now needs to take that string, eggs, pancakes, waffles, find the menu item data structure, Y, so it can get the price, it can get the ingredients to give to the chef and so forth. But when I run this right now, hey, wait a minute, the interpreter saying, I don't know how to compare a string with an object or a class, but I can make it work that way. So inside my equality, right? You should have learned this from Zybooks, and I saw some people use this already, which is great. There's a function called isInstance. So I can say, if other is an instance of a menu item, then do this comparison of their names. Equally, I can say elif is instance, if other is an instance of a string, Now I can say return true if self.name equals simply other, because other, if it falls into this block, is a string. So now when I run my code, I shouldn't get an error. Let's see. Return true if self equals other, or else false. So now when I run that, eggs, the string, equals eggs, the menu item. Now, do eggs equal fried eggs? Well, no, that's false because it's just doing this comparison. But I could put logic in there that said something like substring or index of eggs if it was somewhere in there, right? So you can have some fun with that. Okay, so that's all of classes. We're not going to be learning anything new with classes from this point forward. Reminder for the assignment 9, right? One of the things we're going to be watching for is your progression. So if you submit this thing and you ran your test one time, you're not getting higher than a 67 on it. We need to see that you wrote 2-3 lines of code, ran the test. Wrote 2-3 lines of code, ran the test. If you try to game this, it's going to be apparent. So please don't game this thing, right? I need to make sure that's working properly because when we move into 10, inheritance, y'all are going to be on your own, writing your own classes, right? And so I have to make sure you know how to do that. So, all right, as a reminder, Wednesday we will be picking up with 10, chapter 10, inheritance. These are the 2 chapters that we will be covering, or the 2 sections. I announced earlier that quiz 9 was going to be Wednesday. I moved it to give you a little extra time to catch up. So the quiz again will be split on Thursday and Friday. So we'll have part of it during lab and then the second part on Friday. We will be working in lab on project 1. Hopefully I'll get project 2 out tomorrow for everyone. That's what we will be doing in this lab period. We will not be doing the inheritance lab because we haven't covered that material yet. Friday, though, we will have the quiz, the other part of that quiz. The homework for 9 on classes is due, and then we're ready for our exam. Next Monday, I'll be doing exam prep in class, so I'll get that test exam out. Offering to do another code jam from 4 till 8 up in Martin. Tuesday, same thing, 4 to 8 up in Martin. Anybody wants to practice? And then Wednesday, the 11th, we'll be doing exam on functions, files, and classes. All right. I have office hours now. Come visit me up in 454. Happy to work through the assignments, go through files, whatever y'all need. Take care. All right. I've been 10. People kind of roll in and roll out. We'll just hang out for a little while and, like, you know, if it's covering material they already know. No, but I usually just do like, hey, what do y'all want to work on? Hey, let's go through. If data structures.